Welcome everybody to day one. I have this titled as 1.0 because this is before we even get started in on trig. So you can see we're going to be talking about some prereq and fundamental concepts that hopefully you know and I can elaborate on throughout the class. All right. So what we're going to start with is one of the most important concepts in all of math. And you may not believe it. Anybody know what it is? I don't expect you to. But it is called, I put wait for it, keeping you guys on the edge of your seats already. It's called the identity property. Okay? And the identity property is a property that allows us to have an identical saying or sentence. And the symbol that we use for that is very, very easy. It's the equal sign. And how we get, if we have anything, I just put A, the identical symbol or whatever it might be, is by multiplying by 1. Yes, my friends, I am saying that multiplying by 1 is one of the most important concepts in all of math. You're like, all right, I think I'm going to do well in this class. Okay. Now remember, the symbol we use to mean identity or identical in mathematics is equals. So whatever we have on the left side, if we put this, that means it's equivalent on the other. And so obviously we would have A. Okay. What's going to be the tricky part about all of this, both in this class and previous, all the way through elementary school? You guys have been using this. You just didn't probably have a name for it. Is figuring out what this is. And you're like, well, duh, that's a 1. Yeah, but the 1 can be different, right? This is also a 1. So is this. And even so is this. So 1s come in all shapes and sizes and formats, as you can see here. Okay, so this, and this are going to be some of the things that we have to deal with throughout this course and beyond. Okay, so I threw a few examples together of when you've already been using this type of idea. So I'm just going to run through this with you guys. Obviously, you probably, I should say, know how to do this. But if you look at example number 1, this is one of the most missed questions by seniors in high school taking the SAT. Yes, you heard me right. 1/2 plus 2/3. How can we add things? Well, remember, in order to add, things have to be alike because we're trying to add more to something. And if the two things aren't the same, then we can't add and say we have more of them. So what we're looking at is the numerator versus the denominator. And you know the numerator represents the number of things that we have, where the denominator represents the denomination, what we have. So I have 1 of these, what we're calling halves. I have 2 of what we're calling thirds. And I can't just add those across and say I have 3/5, because we never had any fifths. But I can do that fancy multiplying by 1 that we talked about to both of these things in order to get a common denominator, we called it. So I'm going to multiply by 3/3 and 2/2, which are my fancy ones. And that will now allow me to have an equivalent or identical statement that would now be 3/6 when multiplying across and 4/6. Which means I now have a bunch of 6, which allows me now to actually add those 6 to get more 6. And how many more? Obviously 7. Okay. So again, just trying to do a quick review, get you guys refreshed on math, and show you that you've actually been doing things like this for a very long time. Are we going to sit here and add fractions in this class? Not so much. But we will at some point, and we will also deal with what are called radicals. And we don't like dividing by things that we don't know. Who can tell me what the square root of 2 is? Some of you guys are trying to get out your calculator. Go ahead, Sonny.
I don't know it off the top of my head.
Exactly. So if I gave you the square root of 1 or the square root of 4, you know exactly what those are. What's the square root of 1?
1,
What's the square root of 4?
2.
So since the square root of 2 is somewhere in between there, I know my answer has to be somewhere between 1 and 2, which means we either have to introduce fractions or decimals. Ugh, no thanks, right? We know that we don't like working with fractions when we don't have to. So since we don't know what this is off the top of our head, we'd have to use a calculator or some type of chart. We'd rather get rid of it. And this is what is called rationalizing the denominator. Do you guys remember this? Do you remember how to get rid of that root on the bottom? And I'm going to put air quotes around get rid of.
You multiply the top?
Close. Can I just multiply the top by something?
Yes, no.
If I just multiply the top of this by 3 and not the bottom, I'd have 3 halves.
You'd have to
Yeah,
multiply
I have
the top
Divided by the
by
square root on top.
square root of 2 over square root of 2,
That's right.
which is also 1.
Very good. You guys are starting to see the theme here. And if you can crack this code, you're going to be better off in this class and future ones. Okay? I can and only can multiply by a 1 to get something that is identical or equivalent. If I multiply by anything other than 1, anything, it will either be bigger or smaller. 1 is the what is called identity. You will get the identical. It just may look a little bit different. Instead of 3/6, what we had originally was 1/2. But by multiplying by this fancy 1 here, I was able to get something equivalent to it, but a little bit different looking than my original 1/2. So again, by multiplying by this fancy 1, we know that we can multiply across and get 1 times anything is itself. That's why we're doing this. And then careful, what's a root 2 times a root 2?
2.
Good. It is the square root of 4, which we could say is just 2. So now we have a little bit nicer looking something that has a denominator, something that we're trying to divide into the top that we do know. We know the value of 2. Okay, so that right there is called rationalizing the denominator. Okay. Other looks that we will see is when we are asked to change from one thing to another. Now in this one, we are given what is called a rate. Are you guys familiar with rates? Also known as speed.
Yes.
20 miles per hour, I don't know if you guys realize this, is also a fraction. If I was to write it as 20 miles per every 1 hour, do you guys remember the distance formula? To find how far you traveled, what would you need to know?
Rate and time?
Very good. How fast you're going and how long you were going that speed. But if I wanted to find the rate, the speed that I was going, I'd have to solve this for r. And all I'd have to do is undo the multiplying, and that is dividing by t, because we know anything divided by itself is that 1. So now, if you notice, I have the r, my rate, is equal to the distance over time. And that's exactly what we have here. A distance happens to be in miles over time, which happens to be in hours. Now, if any of you guys are baseball fans, that's how we measure the rate or speed that some pitchers throw, miles per hour. Have you ever seen anyone throw a baseball a certain number of miles? Probably not.
Fastest I've seen is like 80 on like one of the baseball games I've watched.
Yeah, people throw actually up to 100 miles an hour. But have you ever seen somebody throw 100 miles or even 1 mile?
Have you ever seen somebody throw a baseball that hasn't hit the ground before an hour?
Exactly right. That's my point. This isn't very good at measuring, but it's something that we're familiar with. It doesn't really make sense to say miles per hour when throwing a baseball. What would make more sense?
Feet per second.
Well, then let's convert it. And let's see what 20 miles an hour, which we know we drive starting next week when everybody's back to schools, right? About that speed, what would it be in feet per second? Well, what's the only thing I can do to this that will change the look of it, but not the value itself?
Divide by 60.
I like that, but I was looking for a more generic answer.
Multiply by 1.
Thank you. That's right. Multiplying by 1, we get an identical statement. Okay. So when I'm looking at this, I want to change that 20 miles per hour to feet instead of miles and seconds instead of hours. So I can multiply. How many times can I multiply by 1?
As many as necessary.
That's right. That's why it's so critical to understand. Now, remember, the ones that we're talking about are going to be a little bit different. Let's talk about changing either one, miles and feet or hours and seconds. What do you guys want to get rid of first? The miles or the hours?
The hours.
Hours.
I knew it. I knew you guys were all going to say that because most of you don't even know how many feet are in a mile. And it's our system. We don't use the one that the rest of the world uses, which if you just got done watching the Olympics the past 2 weeks, it was all in the metric system because that's what the rest of the world uses. It's only us and one other small country that uses our, I hate to say it, crappy system. And it's crappy because it's different everywhere. I could teach you guys the entire metric system in one of these 2-hour sessions.
I want to say it's 5,280 feet in a mile.
Very good. Nice, Jacob. Anybody else know that? Good, Valor.
Had to Google it.
Thanks for being honest, Ricardo. Yeah, most people, and it's our system. We don't even know. 5,280, that's silly, isn't it? So I could go on about the history behind it. It all came because we seceded from England, right? We still had some of their tendencies. You guys know that how many inches there are in a foot, right?
12.
Why 12? Wouldn't 10 have been easier? If you say you're 6 foot, how many inches are you quick?
I'm 5'10".
Whoa.
60 if it was like 10
This
inches.
foot would be 70 inches? Trying to do the math in my head.
Exactly.
70
It stinks. You have to do 12 times 6. But
Oh,
I think it was
70
Michelle. She
inches.
said it would be a whole lot easier if it was 10, because then it's 60. We're done. Well, that's what the metric system does. Everything is in increments of 10, whether it's moving it 10 to the right or moving it 10 to the left. all you got to therefore do is move the decimal, because that's our system that we actually use to count is base 10. So unfortunately, we used a king's thumb and we measured it to his foot. And guess how many of the lengths of his thumb measured to his foot?
12.
12.
There you go. 12 inches in a foot. Boom. Rule. And you know what happened when some other king came along? He wanted another rule for himself because he's the ruler. So he said, you know what? I'm going to do you one more. I'm going to take your foot and I'm going to measure it from my outstretched arm, the tip of my fingers to my chin. And guess how many feet measured to that, which he called a yard?
3.
Rule. Guys, there's no rhyme or reason to this stuff. That's the unfortunate part. Okay. So
So
unfortunately,
arbitrary.
that's what we're stuck with, which is why you decided, you know what, let's wait on the miles. Let's do the hours first. We're all used to that. And if I want to change this out from hours to seconds,
The funny thing is, if I'm doing this conversion, I start with distance because distance is on top.
and that's
Just
the
as
cool
arbitrary
thing,
reason, but
and that's the cool thing, it does not matter because we're just multiplying by ones. Now, what do I want to have up here? And what do I want to have down here?
Feet in seconds.
60.
Good, I want feet in seconds, but right now we're concentrating on hours, right? So where do I want the hours, the seconds? Which one goes where?
Want the hours
Feet.
going to month.
Why do we want the hours on top? What is that going to allow us to do?
Divide by 60.
Just like we did over here, right? We're going to be able to cancel those like things. So the hours will cancel out. And we said we wanted seconds in the bottom of this fraction. So I'm going to put the seconds down here. Now, the problem is, do you guys know how many seconds are in an hour?
3,600?
Yeah, most people don't, Jacob. Stop doing extra math. Okay. Very good. What most people do know are minutes in hours. And we know in 1 hour, there are 60 minutes. That's a one that we do know. And does everybody agree that this is a fancy one here?
Yes.
Cool.
Yep.
The problem is, even though that's what I want, so that I can cancel and get rid of the hour over the hour. And now I have miles per minute. That's better, but that's not what we wanted. I'm going to have to multiply another fancy one over here to get rid of the minutes, which is currently on bottom. So I'm going to put it on top so that they will cancel out. And I'm going to put the finally thing that I wanted of seconds on bottom. And do we know a direct relationship between those two things?
1 minute equals 60 seconds.
And you said equal, which means since these are the same, they will cancel out and just be a 1. Very good. So that allows me, again, one more time, to cancel out something that I didn't want, the minutes over the minutes. And finally, the only thing that's left on bottom is our seconds that we wanted. Now, Jacob and everyone else, now you can see why it's 3,600 without just Googling it. Ricardo. But we still now have miles per second and we wanted feet per second. So unfortunately, we have to multiply by one more 1. And this time we want to get rid of what?
Miles
Miles.
And where is it currently?
on the top, so you put it on the bottom.
Very good. Very good. So I will put the miles on bottom. And what do I want on top?
Feet.
I want feet. Should I put it there?
yards.
If I know a direct relationship between the two, then go ahead and go for it. We don't need to do everything in between, like somebody mentioned yards. We could do that, but it's not necessary for this one because we do know how many feet are in 1 mile.
5280.
5,280, which
You're
then allows
welcome.
me to cancel the miles over the miles because we are multiplying all of these things. And so I'm just dividing. And anything divided by itself is 1. Does that make sense?
Yeah.
So the only thing that would be left to do is grab your calculator and multiply this out. There is some canceling that you could do. You could go ahead and divide the 20 by the 60 if you wanted, or the 60 into the 5,280, or at least divide by 10. But you're going to have to end up putting that in your calculator anyways, so it's totally up to you. I just wanted you all to see the process that we then changed what we originally had in miles per hour to feet per second. So these are the types of things that we'll be doing, but in a different format. Okay, with angles and circles and triangles and all kinds of fun stuff. Okay, another thing that we will do and see is taking something like this and either adding or subtracting something similar. So I'm going to go ahead and stack it. I'm going to put 5 yards, 1 foot, and 7 inches, and I'm going to subtract from that the 3 yards, 2 feet, 10 inches from it.
And for those of us that did the homework, this is basically what we were doing with the degree minute second rotation notation.
Look at you making connections already. Very good, Jacob. I'm just trying to make it more relatable so that you guys can then make that connection. Very good. So where do we always start? Well, I could take 5 yards and subtract 3 yards and know that I have 2 yards. That's not a big deal. But when I have something like this or this involved, and I have only this many, and am asked to subtract more than I have, we have to do a little thing called what?
Borrowing.
And we have to borrow from the next biggest thing. And again, that's because we have that direct relationship. Okay. So I'm going to go over here and I'm going to borrow from this 1 foot, which would now give me 0 feet. But here's where a lot of people make mistakes. That's what they'll put. We just got done reviewing how many feet and how many inches are in one another. So if you borrow a foot and give it over here to the inches, is it just going to be another group of 10?
Be 19 total inches.
Very good. We would be taking that 1 foot and actually adding 12 to that. So we'd have a total of, like somebody said, I didn't see it, sorry, 19 inches actually, not 17. But now does that allow me to subtract? That's the easy part. The more challenging part is when we borrow, it's not always a group of 10, like when we grew up in elementary school and we learned how to count. Okay, so now when I go to the next measurement, which is feet, I have none because we had to borrow one to make sure we had enough inches. And I'm trying to subtract 2 feet from that. So I need to go and borrow from my yards. So I will borrow 1 here, which means I now have 4 yards. And does that mean I now have 10 feet?
You have 3.
Oh, you have 3 feet. Only 4.
You guys are starting to get the idea, right? I'm going to cross that out and put 3 rather than putting the 3 in front and thinking I have 30. Okay. But we only borrowed 1 yard, which only increases our feet by 3. And so now we can subtract, and 3 minus 2, 1 foot. And then lastly, 4 minus 3 would give us our 1 yard.
I have a question.
Yes, ma'am.
So when we took the feet, we used one of them for the inches. Do we use both of the 2 feet?
So remember, what we had was just 1 foot. We were subtracting 2 feet. We're not touching the bottom.
Okay, I thought we had 2. My bad.
No problem. This is why I'm doing this, is just to start us off, get us back into math mode. All right, good question. Last thing I wanted to review with you all was solving equations. And I gave you 2 different looks. One that is called a linear equation because we only have a power of 1. And if we were to graph something like that, then it would look like a line. And another that's called, anybody know? When it's a power of 2?
Exponential equation.
Careful, Anthony, go ahead.
Quadratic equation.
Yeah, very good. That is called a quadratic. Exponential is a little bit different. That's when these 2 things are reversed. When we have, say, 2 to the x, and the x is in the exponent. Okay. This highest degree we call of the equation, it's called a degree. That highest power will tell you how many possible solutions there are. So for this one, it's pretty obvious and easy. We can combine and take those 2 x's that we currently have and make them into 1. So I'll take that 4x plus 7x and rewrite it as what?
11x.
Good. And now that I have one equation with just one variable, I should be able to get that thing by itself, or what we call isolated. And all you have to do is what is called the inverse. The reverse of what's being done to it and what is currently being done to it.
It's being multiplied.
Good. By what?
11.
Oh,
So how are we going to undo multiplying by 11?
Divide each side by 11.
Oh, I like how you said each side, because what did we say this symbol meant?
One.
Could be.
both sides equal the same thing.
They equal the same thing, right? We knew multiplying by 1 kept it that way. But this meant the big push right now, right? Equality. The 2 sides are equivalent. And as long as we do something to one side to keep it equal, we got to do the same thing. All right. And like we just mentioned, what happens when we divide something by itself?
Cancels it out.
So we get 11 divided by 11, which is
1.
1.
and now I have that 1x, which is what I wanted to know. Now I'm going to teach you guys some new ways to do things that you already know how to do, to not only expand your mind, but also to give you some cool little insights to how math can be different and fun. How would you take 11 and divide it into 143? Most of you would just pull out your calculator like you're doing and figure out that the answer is 13, right? But what I want to show you is how to do long division without the long part. If you were to do this and set it up over here, the first thing you would have done was try to see how many times 11 goes into 1, but we know it doesn't. So then we look at the 14. So if you just look at this, you should be able to do that. How many times does 11 go into 14?
1 time.
Just once. But when you put the 1 up here, and then you put the 11 and you subtract, you're just finding the difference. And you know that the difference when you put 11 into 14, you'd have a difference of 3. And then we knew we'd bring down that 3 And now we're looking at how many times 11 now goes into 33. And can you do that in your head? Hopefully.
It's 3.
And now you just did that in your head very quickly without doing the whole long division setup. Okay, so I'm going to, again, try to teach you guys different ways to think. All right, on to the last one for this section, and then we'll get into the trig part and then open it up to the group quiz. When we have more than one x, we tried to combine them so that we can get one x and then isolate it and get it by itself and provide the answer. The one and only answer that made this true or equal. Over here, we can't combine these. So we have to find a new technique. And our quickest, easiest way to solve something like this is also the inverse. It's undoing the whole multiplying out to get that trinomial. It's called factoring. And hopefully you guys remember how to factor. If not, we'll do a little bit of review in the group quiz, which I'm sure some of you are already working on. But I know that when I FOIL distribute this out, I have to have an x and an x there to get my x squared. Then I like to start at the other ends and figure out what multiplied together would give me a negative 16. Problem is there's options there. The one thing I do know that has to be true is that one of them has to be positive and one has to be negative to make a negative 16. And what's the first thing that comes to your mind when you think about multiplying to 16?
4.
8.
Good. Some people say 8 and 2, some people say 4 and 4. That's where the middle comes in. You have to see which of those two pairs, either the 4 times 4 or the 2 times 8 or the 1 times 16 or any other pair that comes up.
It has to be -8 and +2.
That give you, careful, a -6. And it has to be -6. So which one would have to go where? Well, if you just look at the sign in the middle, that tells you that the bigger number has to go with that. So I'd have to have a -8 and +2 to get my -6x in the middle. Now remember, we're not quite done because we know when this factor times this factor equals 0 will only ever be true when either that thing is equal to 0 or that thing is equal to 0. Because we know 0 times anything is 0, always. Right? So in this case, all we have to do is figure out what +2 would give me 0 and what -8 would give you 0. And if you only ever have an x in front, it'll always be the what of these. It is called the opposite, my friends. The opposite of 2 is -2. The opposite of -8 is +8.
Can you scroll down a little bit? I can't really see it.
Yeah, that might be because you have the thing situated to be on the bottom row. You can drag that to the side or up top for the zoom. So that's it for the review of all the things that we're going to talk about. And it's a perfect segue into our 1.1 angles. Now, you guys aren't going to have anything on your group quiz about this just yet. I just wanted to keep it very basic with some of the algebra and geometry that you hopefully remember. We'll start in on the trig stuff on group quiz 2 next week when we wrap up chapter 1. Okay, so angles is what 1.1 is titled. And so I'm going to start you with the number line, which we just mentioned a little bit over here. Most important number on the number line is what we start at, and that's with nothing. right? Then we knew to the right, we said would be positive numbers. To the left, we knew would be negative numbers. And we said that we could make whole numbers, 1, 2, 3, 4, and everything in between as well. Okay, but we're way beyond that. We've gone all the way up through algebra. And that's when we said, all right, well, then let's talk about when there's another entity that we need to discuss. And that's when we introduced a thing called the X and now Y axis. So this is still going to be to the right, positive numbers, to the left, negative numbers like our number line at that value of 0. But now we're going to have another set, another number line where up we decided was positive and down we decided was negative. And if you notice, what we actually cut things into was 4 parts. And so therefore we like to call these quadrants, because there's 4 of them. And which one do you think we named quadrant 1?
Top right.
How come?
I just watched the video yesterday and I don't remember already.
That's why we do these
Because
things.
it's positive on both
Is it
axes.
because they're both positives?
Very good. To get there, if I was to give you an X and a Y value, which are what we call points, ordered pairs, order because of the alphabet, pair because there's 2, then that means I would be, to get here, giving you something that's both positive in the X and the Y. So this is what we call quadrant 1. Now we had a choice. Do we want to go here for quadrant 2 or do we want to go here for quadrant 2? Probably not all the way over here because then we'd have to skip something to get there. Well, since we started with our number line, which we're now calling the x-axis, we're going to switch that first because we got to change one of them to be a negative. So which one would be our quadrant 2?
The left.
Because that would be a negative in the X and still positive in the Y. And of course, you can kind of see the pattern. If we're going to go from here to there, then obviously we're not going to skip and go to here for quadrant 3. So we're going to keep that smooth transition all the way around. And we will get quadrant 3 here and quadrant 4 here, which would be now a negative negative and a positive negative. Okay, but remember the title of this was called angles. We're just talking about points and quadrants. What if I wanted to give you an angle measurement? How do you think we'd represent that? Well, instead of just giving you a point and saying it's x comma y to get there, and I'd go right x and up y, what else could I give you?
The degree, possibly.
Good. To get there, I'd start at what is called the origin, and I'd go right x up y. But to get to that point, wouldn't it be easier rather than going right some and then up some to just go directly there? Isn't that the quickest way to get from one point to another is a straight line? Well, then I would need to know the distance that I'm traveling, and I would need to know the angle, which we're going to use Greek letters to denote that. It's called theta. So instead of giving you an X and a Y, I can give you an angle and a distance. And we're going to call that the letter R. Do you guys want to know why we call it R?
The rate.
Close. Good idea. I like you trying to make connections. It
Range?
actually has to do with, what if I kept rotating it?
The radius.
What would I form?
Hmm.
A circle.
That's right. And we hopefully remember from back in geometry that if we have a center and we go out to any point on that circle, these are all what?
The radius?
Good. For plural, we call it radii. So that's why we use the letter R. Awesome. So we will talk more about all the different types of angles. And we will start classifying them. And of course, what I just mentioned a bit ago, which way is positive for the x-axis, which way is positive for the y-axis. Well then, what do you think we would call a positive angle of rotation? If I draw my axes, which way are we going to start by looking?
We're gonna start in quadrant 1.
Good, we'll start at the origin and we'll start on the positive x-axis. And then should I go up or down to start rotating? What do you want to be called a positive angle?
Rotate up.
Yeah, because that's positive. So this would be what is called a positive angle of rotation. Okay, so positive rotations or angles are going to be what we call counter clockwise rotations. Again, they go back to a clock because that's something that most everyone knows. Now it's all digital stuff, so not everybody knows, but that's what we mean by counterclockwise. Okay, because what normally does a clock, it starts at the 12 and then rotates this way. But for us, if we're looking to the positive right on our x-axis and we start rotating down, what do you think down means?
Negative.
Negative.
And therefore positive angles versus negative angles. Our rotations would be up versus down. And that is from the x-axis, the positive x-axis. All right. Some of the other types of angles that we're going to talk about and classify. And again, these are things that you should have already seen. Acute angles. What are acute angles?
Less than 90.
Very good. It is an angle that is not only less than 90, it is greater than 0. And the way that we measure angles is by a degree. And you guys know in a full circle, how many degrees is it?
360.
Anybody know why?
90 times 4.
Okay, I like that. If we cut this into fourths, each one of these would be 90 degrees. Why 90? Well, it actually came early on from the people called the Babylonians. And they were very interested in the stars and the sky and the sun. And what they actually figured out by mapping and trying to see the rotation and everything until it came back was that it took 360 days is what they came up with for the sun to revolve around the earth. Now, of course, we know that's backwards, but pretty impressive way back in, I think it was like 500 BC, 300 BC. Pretty amazing. So that's why we think a full circle is 360 degrees. And a lot of people also believe that they chose that number because it has a lot of factors, a lot of divisors. So for us, very good. We're going to start at 0 and go in this first quadrant all the way to that 90-degree angle. And we will call all those little ones in there acute. Now, of course, we know right angles are when what?
It equals 90.
Very good. And we use this little box, half of a square, to denote that it is square. Those things are what are called perpendicular. So then what about obtuse? If we're going from here to here, that's acute. That's a 90. We're going to keep going.
180.
Very good. And we will say any angle that is less than 180, but greater than 90. And notice it's strictly. It does not include the 90 or the 180 because we already included the 90 here. It's called a right angle. And therefore, what do you think we call when it's equal to 180?
A line.
Very good. It is a line, but talking about angles, we're going to call it a straight angle. Because if you were to draw a line, like you said, it's going to be straight. So that's what 180 degrees looks like, is that x-axis or that y-axis, or any line at any angle. Awesome. So what do you think quadrantal angles are then?
Angle greater than 180.
Great comment. I like that you're trying to figure out, well, let's just keep going, right? Let's just keep going all the way around. Well, we actually stop here. And here's why. Anything more than 180, I don't have to go and get. Because if I wanted to get to this point right here, instead of going all the way around,
Just go
get
the other
there.
direction.
I could get there faster by just going the other direction, the negative direction. So that's why we stop at 180, because that is the exact reverse of the way that we're facing. And so anything over here, I'll go positive to get there. Anything down here, I'll go negative to get there, rather than having to go all the way around to get to that same point. So read the word quadrantal angles. What do you think those are?
When one of the sides of the angle lies on the x or y axis.
Very good. If I am on one of my axes, whether it's x or y, then those are what are called quadrantal angles. So they are going to be in multiples of what?
90.
Good. So we're going to say it starts at 0, goes to 90, then what?
180.
Then what?
270.
Good. And lastly, to get all the way around?
360.
That's right. So this point is actually either 0 degrees or 360 degrees. It's the same. But sometimes they don't like us to include 0 because it's easier to use 360 or vice versa. Okay, very good. Those are called the quadrantal angles. Now on to a few others that hopefully you remember. Complementary, supplementary, and you may have heard this or may not. It's called coterminal. What do you think coterminal angles are? And just try to break down
Both
the
the
word.
end in the same place.
Very good. Co-terminal. Unfortunately, either from movies or experience, you may have heard of terminal illnesses, especially in the last 18 months, right? Terminal meaning end, terminator, right? Terminating. Co, if you've ever signed up to buy a car or something else and you needed a co-signer, that means they're signing on the same loan because you may need more credit or credibility that you or somebody else is going to make that payment. So if you break down these words, it literally means same ending. And so if I was to give you a point on my circle, and I said, you know what? I'll make it easy. Let's do this point right here. And let's say that that angle to get there is 60 degrees. Who could give me another one that would allow me to get to this exact same point?
Would it be like 420 degrees?
Anthony, how'd you get that?
By adding 360 degrees?
360? Why 360? That's a weird number.
I'm assuming because it's a full circle.
Very good. Remember, if we go all the way around a full 360 degrees, you will get right back to that same point. Now, do you have to only add 360, or what would have been even better?
Could be 300 degrees because you could have subtracted.
Oh, good, but careful. Not 300, but what?
Negative 300?
Yes, and does that matter?
Yeah.
Heck yeah. Remember, positive means we start up and rotate around. Negative means we start down and rotate around. So yeah, that matters a lot. But all of these are equivalent. And could you add 360 more than once? Or subtract 360 more than once?
Yeah,
How many times can you add 360?
as many times as you want, I think.
That is correct. You can continue to add 360 any number of times or subtract it, just like we talked about with multiplying by 1. It'll get you back that exact same thing. Very good.
360 is 1.
Almost. It's a good way to look at it on this. Now, last thing you guys may be familiar with is complementary and supplementary. Do you guys remember this from geometry way back when?
Yes.
Remember the key things that we talked about up here, if you notice on all those angles we classified, was what did they all have in common?
Add up to 90.
Or
180.
yeah, so those are the key components. So when we're talking about angles, more than one angle, we're going to talk about what the sum would equal 90 and when the sum would equal 180. And how are you going to remember which one is which? It's very simple. Use the alphabet. C comes before S in the alphabet. 90 comes before 180 when you're counting. So complementary is the 90-degree sum. Supplementary is the 180. What do those look like? A right angle. And if I had it split and I had angle 1 here and angle 2 there, we know together they would have to add up to 90, or that straight angle And again, throwing a different one, there's angle 1, there's angle 2. We know that those two would have to add up to 180. Does not mean that they're always the same. Okay, depends. If that was split right down the middle at 45 degrees, then yes, both of those would be 45. Okay. So the last thing we'll talk about is the more precise measurements of angles. And this is something that Jacob alluded to earlier. How can you get more precise on your numbers? Say your measurement of your height. We know we can do how many feet and how many inches. I think Ricardo said he was 5'10". Are you exactly 5 feet 10 inches, Ricardo?
I wouldn't say exactly.
Exactly. So what would we have to do to get more precise? Well, we could get decimals or fractions involved. Well, with angles, it's very, very important when dealing with certain types of things in the real world. So what they created were these things called, we know degrees, and we can use decimals for precision, but there's also this thing called, within degrees, we can break them down in what are called minutes and break those down even smaller into what are called seconds. Now, you might be wondering, like, well, I already know minutes and seconds, that's time. Well, the only difference with angles in these is that the measurement that we're going to use for these, for minutes, is we need to know that 1 degree you can get by creating 60 minutes. So we're just going to take 1 degree, which if we took a whole 360-degree circle and we cut it into 1/360th, a tiny little slice. Well, now we're going to take that tiny little slice and we're going to cut that into 60 parts. And that's what we call a minute. So rather than just using our decimals, we're going to use these new symbols and these new quote unquote words called minutes and seconds. So the cool thing is you're already familiar with these, but it's going to take a little bit of time to get used to, because we know that 1 minute is created by how many seconds?
60.
And you guys may have seen these over the last couple weeks if you're watching track and field or the swimming, because it comes down to very, very close times. Because of how fast these people are, they got to go down to the tenths or hundredths of a second. So this is the new thing that you have to make sure that you memorize and be able to use. And we will do things like this, which for short, we'll call it DMS, degrees, minutes, seconds, or over here, decimal degrees. The cool thing is, you guys already know that 60 seconds makes up 1 minute. And that 60 minutes makes up 1 hour. The only thing that you have to change now for measuring in this class is that 60 minutes makes up 1 degree. Okay? So that's it for me today. I wanted to make sure that I give you guys a nice introduction into some of the things that we'll be using for not just this class, but many courses in the future. The multiplying by 1, solving equations, and then a little bit of an introduction to all the different definitions and things in this very first section.